Okay, this is the first video on chapter 8, trigonometry and its calculus. In this very first section, we're going to review some concepts and some questions about the angles and the triangles. And here are objectives. You do not have to write it down because there are slides that cover those. And so here basically we're going to see how do we find coterminal angles of a given angle, and how to convert the radian measure to degree measure, and vice versa, and then use the formulas that are related to triangles. Okay, first about angles and degree measure. And so first recall what are the ingredients or parts of an angle. An angle has three parts. And let's see the picture here. Angle and has a vertex. Vertex, okay, which is right here. Red vertex. And the two sides, or that are from the vertex. And one side is called a terminal side or initial side, and one is called a terminal side, another one is the initial side. Okay, so so initial and the terminal side. So here is an example. Yeah, here's an example. Now, if we have a coordinate system, coordinate system for a plane, and if the so like this one, so here's x-axis, here's y-axis, okay, and here's origin. If we position the vertex to be the origin and the initial side or initial rate to be the positive x-axis, then then we call the position of the angle in standard position. So that's what we mean. I will not write down here. So the standard position of an angle is when the vertex is the origin and the initial side is the same as the positive x-axis. Okay, so okay, now let's look at some common examples, common angles. Okay, so some common angles here. Okay, again, if you need to draw those angles, you can pause the video if you did not print out the fill-in notes. Let's start with the angle that is kind of easier to understand. Suppose we have an angle where the initial side here is the same as the terminal side. Okay, in other words, we have a full circle, okay, or full revolution. Then we know that the total measure is 360. Yeah, and the 360 is the measure of a full revolution. Now, if we have half a circle, okay, which is also called a straight angle, then the measurement should be just half of 360. That's 1 180. And how about a quarter? Okay. A quarter here is the will be a right angle, right? A right angle is right here. Right angle here. The measurement is 90 degrees. A right angle is a very important angle. Now, if you have an angle that is between 0 and 90 degrees, okay, then it's called a acute angle. And now, if you have an angle whose measure is between 90 and 180, then it's called obtuse angle. So those are the special and some common angles. Okay, now let's look at another important concept. Look at the angle here. This is the initial side. This is the terminal side. Okay. Notice that there are two angles formed by by the two sides. The one angle here is this one here. Okay, and in this case, it is 315. Yeah, 315, positive 315. But we can also rotate the initial side, clockwise. Okay, and so we have another measure of the angle. This positive measure here is 315, and this negative measure here is negative 45. Okay. It is negative because that's our kind of tradition. If the angle is measured counterclockwise, it's positive. If it's clockwise, it is negative. Okay. It is pretty much like like an axis. Here's origin, here's x-axis. So depending on suppose you're given a point on the axis, depending on how you get to the point from the origin. If you walk to the right, you get that's positive. For example, this is positive 2, and here it will be negative 2. Yeah. Similarly, you have different ways to measure an angle depending on the revolution is counterclockwise or clockwise. Okay. And notice that those two angles, 315 and negative 45, they have the same terminal. And such angles are called coterminal angles. So here, what is the condition for two angles to be coterminal? And so it's like this. So suppose I have two angles, alpha and beta, are coterminal. Okay, if the difference between the two angles, okay, is 360 or a multiple or n times 360, where n is an integer. Okay, so the difference could be 360 or negative 360, or it could be any integer times 360. Now 360 is the full revolution, full circle. So so we have the concept of coterminal and the concept of positive measure or negative measure of angles. Now let's look at some examples. Now here we are given 3 angles. Okay, AB, actually 4 angles, A, B, C, D. and we wanted to find a coterminal angle theta of each, of the angles, so that theta is between 0 and 360. And here's the method. The method is outlined here. Okay, to find the coterminal angle of a given angle, we just need to add and subtract 360 until you end up with an angle you want. Okay, in this case, we wanted to find a coterminal angle that's between 0 and 360. So let's look at the first example. The angle we're given is 455. It's easy to see that 450, I'm sorry, is greater than 360. So let's just start with subtracting 360. If you subtract 360, you get 90. And this angle is already between 0 and 360. So that's your answer. Okay, so in other words, 450 and 90 degree are coterminal. And in fact, we can check that, to get what is 450. Well, you first rotate 1 full circle, that's 360, and that's 360. And then you continue to add 90 degree to get a 450. Okay, so 90 degree is the coterminal angle of 450. Okay, that's for A. How about a B here? Well, B here, the angle given is 750. Well, it is certainly greater than 360. So you can start with subtracting 360, and turn out if you do that, so theta equal to 750 minus 360, right? And you will see that this is still 390, and this is still greater than 360. So okay, so you continue. Get a 30. So you just keep subtracting 360 until you get an angle that's between 0 and 360. Okay. Now in this solution here, we just combine the expression. We know we need to subtract 360 twice, because 2 times 360 is 720, which is still less than 750. And the question C here is kind of similar. The angle that we're given is negative 160, so it's a negative number. In order to get a coterminal angle that's positive, so we need to add instead of subtract. So we need to add 360. We start with that, and then we get an angle that is positive and less than 60. So that's the answer. So 200 degree is the coterminal angle of negative 160. Now in the last example, we have negative 390. Well, in this case, we can start with adding 360, and we will realize that if we only add 360, the resulting angle is still negative. So we need to add 2 times 360, and in other words, we need to add 720 degrees, and the result is 360. It's positive, and it is less than 360. Okay, and this graph here shows that how it's working. Okay, so negative 390 means that when this is this angle here. Okay, that's negative 390. Okay. And this terminal side is the same as the terminal side of positive 330. So they are terminal angles. Okay, so that's about those. Now let's go to another way to measure an angle. Okay, another way to measure angle comes from the following fact. Okay. If we position the vertex of an angle at the center of a unit circle, then the length of this sector, this arc length, is proportional to to the angle theta. In other words, if theta is bigger, then the arc length is longer. Okay, so so then people just say, well, why don't we just use the length of this arc as another way to measure the angle? It's just like people use different system, metric system or English system to measure the length of a object. Okay, as a distance measure, for example, it's a different system. And so to decide how do we convert the two, measurements, let's go to the next slide. Okay, again, let's consider a full revolution. Okay, so I have a circle here, and suppose the radius is 1, and consider this angle here. That's a 360, right? And for a unit circle, the circumference is 2 pi times the radius. So it is 2 pi times 1, that's 2 pi. In other words, we have 360 degrees is same as 2 pi, okay, radians. Or if we divide, both sides by 2, we get 180 is the same as pi radians. So this is the basic relation. If we continue, we see that if you have 1 degree, it will be pi over 180 radians, right? Okay. We can also divide, this, by pi, and then we get 1 radian is equal to 180 over pi degrees, like this. So depending on we wanted to convert, a radian to degree, or degree to radian. Okay, so this one is used, to convert degree to radian. Okay, and the second formula is to convert radian to degrees. Okay, So those are the basic formula. Just need to multiply, you know, pi over 180, or multiply by 180 over pi to your, you know, to the measure of your given angle. Okay, so let's look at some common angles and their measures in different in the different system. Okay, again, let's start with this one. That's a pretty. We just talked about that. 2 pi is radian is the same as 360 degrees, and pi radian is the same as 180 degrees. So those are the basic ones. Just keep that in mind. And if you divide, you know, both sides by this one by 2, you get 90 degree is the same as pi over 2 radians, right? Okay. And so those are the kind of special angles. The most important special angles are here. Okay, here, you know, theta equal to, you know, 30 degrees, which is same as pi over 6. Okay, and theta equal to 45 degree, which is same as pi over 4, and theta equal to 6 degree, which is same as pi over 3. They are the most important special angles that we need to be familiar with. Okay. Of course, we also have those special angles. Okay, pi over 2, pi, 2 pi. Actually, there's one more. That's theta equal to 0 degree, which is the same as 0 radian. Okay, and that's one more special one. Okay, so those special angles are the most important ones. Okay. Okay, and we're going to skip this slide and go to the next example. And we're going to just look at one example. Okay, look at 1A. Okay, 135 degrees. I want to know how many radians are in this angle. Well, we start with the angle we're given, and since we're going to convert it to radian, so we're going to multiply by, you know, pi over 80. Okay, now we can you know, keep the units to that list, so we know how it is canceled. Okay, so if we keep the degree, here's the degree, and this ratio has the unit radians over degrees. So degrees canceled, you end up with 3 pi over 4. You can simplify this. Okay. 135 over 180 times pi. Now you do not have to write down all those you know, units. You can just write this. You know, 135 is equal to 135. Just drop the degree and times pi over 180, and then you simplify this, get 3 pi over 4, and then you remember now this new quantity has a unit radians. Okay. So I'll skip the part B, and I will write down the answer so that you can check for yourself. Okay. So here, actually, it is still on this slide here. So you can work out the details. Okay. Negative 270 is equal to negative 3 pi over 2 radians. Okay, now let's do another example where we convert radian you know, angle into degree angle, degree measure. Okay, and that's the to part B. And the part A, the answer is actually here, but we're going to, yeah, let's just do part B. Okay, actually, I'm going to write the answer here. This is negative 90 degrees. And for this one here, I'm going to show the work. Remember to convert an angle in radian to degree. We need to multiply it by 180 over pi. Okay, that's the measure of 1 radian. Okay, and so if we simplify this, cancel pi here, cancel pi here, and and also cancel here, and 180 divided by 4 is 445. And you simplify this, you get 315. Okay, that's it. That's the answer. Okay, that's good. So let's now move on to the next topic, where we're going to talk about some facts about triangles. Okay, again, this is just a review, so we will move quickly. And again, we are going to list some properties of triangles. So I will go over quickly, but you can pause the video to take notes, or you can look at the handout. Okay, so here are the first 3 facts about right triangle. Well, the first, oh, I'm sorry, this is not for just for right triangle, just for any triangle. So the first one here is that if you have any triangle, if you add up the 3 angles, you are going to get a 180. And it doesn't matter what does the triangle look like. Okay. So if you have A, B, C here, then you have A plus B plus C is 180 always. Okay. Second one, the sum of 2 acute angles of a right angle is 90. Okay. Well, that follows from first one. Okay, because one of the angle is 90, so the other 2 will make, 90. So here, suppose this is angle is A, this angle is B, this angle is C. C is 90, and A plus B is also 90, because the sum of all 3 is 190. Okay, so here is a right triangle. Okay, that's number 2. Okay. Number 3 is the well-known Pythagorean theorem. Okay, it says that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. Okay, so this is the the Pythagorean theorem. Okay, this is one of the most useful fact about right triangle. Okay, let's continue. And next page, it's about similar triangles. The 2 triangles are similar, okay, which means they have the same angles. Okay, so look at those 2 here. Okay, here, even though the 2 angles, they have the same, and they have different, dimensions. Okay, but the angles are the same. Okay? As a consequence, then the ratio of corresponding sides are equal. Okay, so for example, if you, for this smaller triangle, if you consider A over B, and for the bigger triangle, here you consider big A over big B, and the two ratios are the same, even though the AB and capital A, capital B are different. Okay, that's number 4, similar triangle. Now you might remember there are different ways to determine whether two triangles are similar, but basically the two triangles are similar means they have equal angles, equal measures, their angles. Okay, number 5, it's about the area formula. So number 5 here, this is you have a triangle here, and how to determine the area? Well, suppose this is the base B, this is the height, then the area of this triangle is A equal to 1/2 B times H, like that. Okay, the formula here. Okay, those are formulas that you already know. And we're going to look at some important and special triangles. Okay. They are very special, but also very important. Okay, number 6 here, we talk about the equilateral triangle. Okay, a triangle with 3 sides are the same, 3 congruent sides. Okay, so for example, if you have S here, S here, S here, okay, and then these 3 angles will be the same. That's 60. Okay, so that's number 6. Number 7, it says that if you have a isosceles right triangle, so like this, it's a right triangle, but the 2 legs are the same. Okay, so for example, this is A, this is A, this is C, like that. Somehow it's like A and B are the same. Okay, in this case, we know this is 90, and this must be 45. And this is also 45. Okay, that's about 7. Number 8, okay, basically it says that if you have an equilateral triangle, as in 6, then the altitude is considered altitude here. Then it's going to bisect the base. So that means this part and this part is the same. Well, that's not surprising because it means this set part is S over 2. This set is also S over 2. Okay. So those are the facts that we are going to remember. And now let's finish with an example here. Okay, suppose we have a equilateral triangle with 1 foot sides, and then we want to find the area. Okay, so here's the how we solve this. Actually, there's a formula for this, which I'm going to give you at the end. But suppose we do not remember the formula, let's see how do we figure out. And first recall the formula. The area is 1/2 of the base times the height. And so we need to figure out what is the height, what is the base. Well, the base here is 1, right? Because they were talking about the equilateral triangle. So the main thing here, we need to figure out the height. Well, the height is the altitude, and it bisects the the base, right? Okay. Therefore, we know that this here is 1/2. We also know this has to be 90 degrees. Okay, so therefore, we have a right triangle here, which is shaded here. And by using the Pythagorean theorem, and h squared plus 1/2 squared, the sum of the square of the 2 legs is equal to the square of the hypotenuse, right? And so let's solve for h. H squared plus 1/4 equal to 1. Subtract 1/4 from both sides. H squared is 3/4, right? Okay, and so h will be square root of 3/4. Now, since the h is positive, we take only the positive square root. And let's simplify that. Take the square root numerator, get rid of 3. Take the square root of denominator, get 2. So that's the height. And therefore, the area is 1/2 b, which is 1, times height. So we end up with root of 3/4. That is the area of an equilateral triangle with side 1. Okay. Now, if the side is S, okay, instead of 1, then the area will be root of 3/4 S squared. Okay, because the base will be S, the height in this case will be root of 3/2S. Therefore, this would be the area. Okay, so we have finished this part, and again, some might be too simple for you, so it's okay to skip some part of the video. Okay, that's good. We're done now. We'll stop here.